Okay, so hopefully you've had a chance to copy this down by now. It says the Singapore Flyer is the world's tallest Ferris wheel. People ride the wheel in capsules. So this is basically a picture, an image of what it looks like. The wheel has a diameter of 150 meters. So I'm going to start just sort of using that info here. We know that that would be 150 meters, right? So we're told that. We're also told it completes one revolution in approximately 32 minutes. In terms of the stuff that we've been doing with sine and cosine, like sinusoidal equations, what do you think that a revolution in 32 minutes is in our equation? Yeah. Yeah, so basically that's telling us the period in our equation, right? Because if it's saying one revolution in 32 minutes, do you see that on our unit circle? I'm going to draw this over here. Oh, I don't know. I'm going to get rid of it anyways. But on our unit circle, do you guys remember that like one full rotation in degrees is what? 360, and what is it in radians? Or 2 pi. It's the same thing. This is telling us that one full rotation or revolution happens in 32 minutes. So it's one period. Good? A capsule reaches a height of 165 meters. Okay, so this is 165 meters, but the diameter is 150. So what can we, it doesn't say it explicitly, but what can we decide based on the information we have here? If it goes up to 165 and the diameter is only 150, then what do we know about this thing? Yeah, so basically there must be like a stand or something at the bottom here, right? That's 15 meters in order for the total distance to make sense. Maybe it's best if I draw it like top to bottom would be 165. We're told the diameter is 150. So the bottom of the capsule, like where you get on, must be happening 15 meters above the ground. Pardon? Kind of unrealistic. I'm pretty certain these are real dimensions. 15 meters, let's think about that. Have you been on a Ferris wheel? You know how you usually have to go upstairs and get to it like a platform, and that's where you actually get into the capsule? This is the tallest one in the world, but yeah, 15 meters? Maybe. I don't know, but this is funny. I hadn't actually thought about it. Yeah. We're going to research it after we're done this to see if this is actually legitimate. I'm pretty sure it is, but interesting. Okay, so it's asking us to determine a function that models the height, h meters, of a capsule at any time, t, after the wheel begins to rotate. So basically, we are trying to use this information to come up with an equation. And let me tell you this is true of any sinusoidal function that we're looking at. I could give different answers. I could have multiple answers. It just depends on what you see first or how you interpret this, but we could give a sine equation as our answer. We could give a cosine equation. We could give different sine and cosine equations, like depending on how we move them left, right, and all that stuff. So I'm purposely going to say that we have to do a cosine just because I want to build in some review and I want to force us to force in a phase shift and all the different components that can happen in an equation. Does that make sense? So I'll sort of talk a little bit more about that as we're going through this, but maybe one of the first things I want to do also, though, is draw this from a different perspective. So I want to draw this. If I would say at the bottom would be the time that they said in, what was it, in minutes? Time in minutes. We already talked about how one rotation would be 32 minutes. So I want to look at one period. You know how it actually keeps going and follows that pattern? We want to zoom in on just one of those periods before it starts repeating again, so that I can draw your attention to the important aspects and again build in that review. So we already talked about how you would start this at 15 meters. So what should go on my y-axis when I go to label this? You can just call it out, anyone. Yeah, that's going to be the height. And our height was in meters because we talked about how ridiculous it is. Okay, so the height in meters. And so if I were to graph this out, what would be my maximum that it goes up to? Yeah, we were told here it's 165. So this is basically just taking the information that's given, starting to organize it so that we can make sense of what's happening. I'm going to put a little dot there because we know that when the time is 0, we talked about this, they're getting on at 15 meters. So that's where we're starting this from. And if that's the case, then what should happen at 32 minutes? Yeah, I should be back at the same spot because that's the whole idea behind periodic patterns, right? It's repeating the same pattern. So if it started at 15, we know that that same pattern is going to repeat there. So then where do you think that our maximum is going to occur? If we're starting there, we know that our height would obviously go up. Where would the maximum, or 165, where would that happen, assuming that it's traveling at the same speed the whole time? Matt? Yeah. Excellent. Does it make sense to everybody that at about 16 minutes, we could say we're going to reach our maximum value, which is up there? So we're starting to get a sense of what this is going to look like when we put this together. We know that, oh, that is very shaky, but that's going to be what our cosine graph looks like. How does a cosine graph usually start? With the maximum, right? So clearly there's been a phase shift, and I've purposely done this. Normally our maximum, like that point, should be starting at the 0 minute mark. But this has moved over, it's slid over. And to be quite clear with this, if I were to keep this going, instead of just doing one rotation, we know that it would keep following that pattern all the way through. But we're just, again, zooming in on one period of it so that we can use it to make sense of our information. So we could have an equation with y, like y equals cosine x, blah, blah, blah. But let's use our function notation to give the specifics or the details. You know how we do like f of x? What would be appropriate to do in this situation? Gwyneth? H of t, good, because what we're saying by writing that is that our height is a function of time. So depending on the time, we can tell which height the Ferris wheel is at, right? And then, actually, maybe just to start things off, I'm going to give it to you in general form. If I were to assume that every transformation and all of that has been applied here, I would have an equation that looks like this. A cosine of b, t minus c plus d. So this is me just giving the general equation of what this would look like without us filling in all the values, where this t that's here is like our x value, but it represents time. So now let's start to fill in what we can, and when we get to a point where we can't fill it in anymore, we will do our calculations to figure out the missing pieces. So the a value that's here, what does that represent, or what is it in this scenario? Well, A stands for what? Do you remember the word? I'm, again, building in review. This is good to do. Ebtine? It does tie in with the vertical stretch, yeah. Amplitude, good. Do we remember that word? So amplitude, and that tells us, like I gave you a little formula to figure out what the amplitude would be. Do you remember that? Or you can tell by looking at the graph. Or just tell me, like, what does amplitude even mean? Yeah. Good. The amplitude in this case is 75. How we get that is we take our maximum and we subtract our minimum, and then we divide that by 2. That's how we got the 75. Here's another way to look at it. Usually on a regular graph, I'm going to get rid of this and just draw it. Like if we had a regular cosine graph, it would look something like that. Everybody good with that? We normally, to get amplitude, would go from the midpoint or the x-axis and we would count up to see like how high up does it go. The problem with this one is that my midline is not on the axis. It's up above the ground, right? So where does my midline on this graph occur? It normally happens at y equals 0, but where is it on this graph? And how do I figure that out? It's not halfway from the maximum to the bottom, but where is it? 15? Mm-hmm. Okay, so did everybody hear Ebtine? I'm going to repeat it and add a little bit to it. So that's absolutely right. We want to take the amplitude, right? The amplitude that we just talked about, so that's 75. And in some cases, that would help us to figure it out. But in this case, it's slid up, right? We have a vertical translation or a displacement, whatever you want to call it, but we've moved it up 15. So do you see that we would add 15 to it? So where is this midline happening? It's going to be at 90. Do we all get that? So we took the 75, that was the amplitude, and then we thought, okay, but the amplitude, I don't start that from 0, I'm starting it up at 15, so I'm sliding that up. So that's how 75 plus 15, that's how we're getting to this 90 and figuring out that that's our midline. Good? Okay, so then cosine of, I'm going to use this, so there's our B, I'm going to do this off to the side. What do we know about the B value? What does it have to do with? The period. We know that it's always 2 pi over B gives us our period. What's the period in this case? The period in this case is 32. I want to work backwards to figure out my B value. So do you see that I can cross multiply these or rearrange them, whatever you want to call it? 2 pi over 32 would be my B value, which is the same thing as what? My B is pi over 16. So in my equation here, I can say the cosine of pi over 16, so we got it from here. I'm going to circle it here and write that there. Bracket T minus, well, what do I minus? Or another way to say this is, how much did I slide my graph to the right? Cosine usually starts with the maximum at the y-axis. So how much did our graph slide over? 16. Do we get that? I want to make this clear. I could have done this without a phase shift. How could I have done this without a phase shift? How would my equation change in order to be able to do this without sliding it? What would do the same thing but no sliding? 15? We could do this with the sine function. What if, just because I want you to, this is going to hurt your brains, but this is good for you. I'm going to say you have to use cosine, but you're not allowed to do a phase shift. So how would this equation be manipulated so that you're not allowed to do a phase shift, but you still have to keep it as cosine? What else would allow us to do that? Somebody other than Evtine? No? Evtine, what do we do? Excellent. We reflect it. So do you guys see that? I'm going to use blue to see that? That's a minimum. Do you see that that's a minimum value? If we make our 75 negative, do you see it would flip it? So a negative 75 cosine would have the same effect as a positive 75 cosine with a phase shift minus 16. Does that make sense? So there's actually multiple correct answers we could give for this. And you'll find this in the workbook, and I'll talk about how that'll show up on your test. But it will most often tell you which version to give the answer in. And that's to be able to restrict it to, one spot. Gwyneth? Yes, what do I put at the end for my vertical displacement? How much did it move up? So the starting point, like the minimum value, moved up to 15, right? This is good review. When we're talking about this D value, our phase shift, that's referring to the midline. So the midline, see here, it's usually at 0. Where is it on this graph? It's at plus 90. So we move this up plus 90. And I should put this is all equal to h of t, but this, and I want to be clear, there was an easier way to do it if we just did negative 75 to just flip it upside down, but I wanted to force you to apply every transformation possible so we could review it. Does that make sense to everybody? If I made it negative 75, I could just get rid of this part. That would be the same thing. Good? I also could have used a sine graph. I could have used a sine equation, and instead I would have started the starting point of my sine graph would have been there. So my point of where I was phase shifting it, do you see it would happen at 8 instead of 16? We're not going to get into that, but I just wanted to at least mention it so that you're aware that there's multiple answers you could have. So in the book, when it sometimes says it has to be between 0 and 2 pi and give a positive cosine equation for blah, 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 that's the reason. It's to sort of zoom in on one portion of it. That was the hard part. Are we still doing okay? Feeling good? Making sense? And okay, don't worry. It will get better as you practice and have a chance to apply this stuff. I think having done that, I think you're going to find this next part to feel easier than what we just did for sure. But estimate the height of the capsule 20 minutes after the wheel begins to rotate. So basically, I plug in these 20 minutes. I feel like this might be the first time this is coming up. Take out your calculators and change them to radian mode. And I'll talk you through it if you don't know how. You must have done that last year. Did you? In Pre-Calc 11? If you have forgotten, your calculator should have a button that says, I'll write it here, either DRG or mode. And you press that until the little D or the DEG for degree at the top, until it changes to RAD for radians, or some of them might just say R. They're all different, but figure your own calculator out. And then do your calculations. And if you're wondering, how do I know when to decide to use radians or degrees? We are dealing with radians in the question, right? So we have pi over 16, and so that's when we are using radian mode. When you're calculating this, and the rest, you can probably punch this in as is, but if you want to simplify first, and or if you want to just be certain, this can all be simplified to give us just pi over 4, then plus 90. Does pi over 4 stand out to you? Or do you recognize it? Good. I want you to be very comfortable and familiar with those special angles in the special triangles for degrees and radians, and pi over 4 is one of them, so that's good to know and to keep in mind. And then when you punch this in, we get roughly 143 meters. It said round it to the nearest meter. So we could say the height would be approximately 143 meters after 20 minutes.